We decided to do our tolerancing scenario on an electric screwdriver. The screwdriver has a hexagonal hole at the end of the shaft of its motor that will be mated with a Phillips head attachment with a hexagonal base. The only degree of freedom the mate will allow is in the translational x-axis, as that is the only direction in which the mate can be broken. The degrees of the mate that will be constrained are the pitch, yaw, roll, and the translational y and z axes. This allows for the Phillips head attachment to sit inside the hole and not fall out when the motor spins. We will use GD&T to control the form, size, orientation, and location of the mating parts.
The forms of both mating features must closely resemble each other. While dissimilar shapes could be inserted into one another, the surface of the screw bit must be sufficiently touching the walls of the slot in order to generate enough torque without creating excessive stresses. This can only be achieved with parts of matching form and similar size. The form of both the bit and hole is a regular hexagon. This shape is controlled by datum features A, B, and C. The surface profile tool requires the opposing side of each datum feature to be within a parallel slab-like tolerance zone of 0.002 inches thick. The internal angles at the hexagon are dimensioned to be 120 degrees. Defining a single angle is sufficient in this case, as the form is completely defined when combined with 3 sets of parallel sides.
The size of the mating features must be within a tight tolerance for similar reasons. The screw bit must not exceed the size of the hole or be so small as to be loose. A loose screw bit will be prone to slipping out. The force exerted on the screw by the slot will also rest exclusively on the corners of the bit. This would potentially create damaging stresses on both parts. The depth of the cavity of the screwdriver is controlled with dimension origin. All points on the surface must lie within a tolerance zone of 0.02 inches thick. The mating part of the bit is controlled with dimension origin to never be larger than the minimum size of the cavity. This ensures the mate will cover the whole bit. The dimension origin specifies the width of the features along with the orientation and location of the tolerance zones from origin planes that are tangent to the planar surfaces.
For the orientation, the slot must be parallel with the axis of rotation established by the motor. The screw bit must rotate about its central axis, and this can only be achieved if the central axis of the bit and the slot are aligned. In addition to being oriented parallel to the axis of rotation of the motor, the center of the hole must also be located on the axis of rotation. The locations of all the features on the screw bit are fully defined by its form, size, and orientation.